Welcome back. In my previous video, I had discussed some question of CSIR NET which had come 2024 June exam about linear algebra. Today's goal of this lecture, today I will see more example about CSIR NET June 2024 question. This type of question actually very important for any competitive exam. Also, I will discuss one question of GATE exam which also had come in 2024 exam. Question is, A is 10 cross 10 real matrix and assume that rank of A equal to 7. Then which of the following is necessarily true? Option 1. There exists a vector V belongs to R10 such that AV not equal to 0 and A square V equal to 0. Is it true option? Here given A is 10 cross 10 matrix with rank 7 matrix. Here consider the matrix A equal to 1 1 1 1 and other is 0 0. This is the 10 cross 10 matrix. This is the A, and notice here A square equal to A. This is the idempotent matrix. Therefore, here the question, there exists a vector V in R10. There exists a vector V in R10 such that AV not equal to 0. Since AV not equal to 0, since this is the idempotent matrix, so A square equal to A, therefore A equal to A square V also would be not equal to 0 for this type of matrix. For this type of matrix, we can eliminate option 1. And option 7, A to the power 7 equal to 0. Is it true? If we consider this matrix, here A square equal to A, then A to the power 7 would be not equal to 0 for this type of matrix, for this type of idempotent matrix. So, this is also wrong option. Option 3, A must have a non-zero eigenvalue. Is it true? Consider a nilpotent matrix which has 8 cross 8 nilpotent block. 8 cross 8 nilpotent block means the rank of the matrix would be 7 because here the 8 cross 8 nilpotent block, 8 cross 8 nilpotent block, this is the 10 cross 10 nilpotent matrix whose rank is 7 and eigenvalue is 0. That means there A must have a non-zero eigenvalue. This is not always true. If we consider the nilpotent matrix, then A must have non-zero eigenvalue, this is not true. Option 2, there exists a vector v belongs to R10 such that a square v not equal to 0. Here given rank of A equal to 7. And we all of us know rank of A square would be less than equal to minimum of rank of A, and this is maximum of rank of A plus rank of A minus n. And rank of A square then less than equal to 7, and this is 7 plus 7 minus 10. That means this is rank of A square less than equal to 7, greater than equal to 4. Since rank of A square always greater than equal to 4, so always there exists a vector v in R10 such that A square v is not equal to 0. So option 2 is a right option. I hope my all viewers have understood this question easily. This is very basic type of question. If you apply some basic knowledge, then you can solve this question easily. Next question which had come GATE 2024 exam. The question is T and S operator from R4 to R4 be two non-zero non-identity R linear transformation and assume that T square equal to T. Then which of the following is and are true? Option 1, T is necessarily invertible. Option 2, T and S are similar, and if S square equal to S and rank T equal to rank S, then T and S are similar. If these two conditions hold, then we can tell T and S is similar. Third, T and S are similar if S has 0 and 1 as an eigenvalue, and option 4, T is necessarily diagonalizable. T and S given from R4 to R4 and given T square equal to T. Assume that T is invertible. T is invertible. Then T inverse T square equal to T inverse T, which is equal to T equal to identity, gives. But given here T and S be non-zero non-identity linear transformation, but here I have got T equal to identity. So T is necessarily invertible. This is not true always. If T is invertible, then T is identity implied. But given T is non-zero non-identity linear transformation, so T is necessarily invertible, this is not true. Also T is necessarily diagonalizable. Since given T square equal to T, this is the annihilating polynomial. Therefore, this is the annihilating polynomial. Therefore, the possible minimal polynomial is x square minus x equal to 0, that imply x times x minus 1 equal to 0. Therefore, the possible minimal polynomial, one possibility is x times x minus 1, another possibility equal to 0, another possibility is equal to x equal to 0, another possibility is x equal to x minus 1 equal to 0. But x minus 1 equal to 0, that imply x equal to identity. This imply x equal to 0 operator. But given t and s both non-zero non-identity operator, this imply t equal to 0 operator, t equal to identity operator. This is not possible. Only possible minimal polynomial is x times x minus 1. And since minimal polynomial has no repeated eigenvalue, minimal polynomial split, so t is diagonalizable. So option 4 is a right option. Option 2, t and s are similar if s square equal to s and rank t equal to rank s. Here given s square equal to s and rank t equal to rank s. If rank t equal to rank s equal to 2, then possibility of ts would be 1 1, other 0 0. This is t and s is 0 0 1 1, possibility of t, because rank t equal to rank s and s square equal to s. And we all of us know pre-linear transformation is similar to Jordan canonical form. Therefore, t similar to t and s similar to same Jordan canonical form. So if rank t equal to rank s and s square equal to s, then t and s are similar. Option 3 implies t and s are similar if t and s has 0 and 1 be the eigenvalue. Is it true? Notice, if you consider t equal to 1 1 0 0, here 0 1 be the eigenvalue, and consider s equal to 2 block 1 1 0 1 0 0 0 0 0 0 0 0 0 0 0 0. Here only diagonal part 0, and here one block whose, this is the upper triangular matrix whose eigenvalue is 1 1, and other eigenvalue is 0 0. Here eigenvalue is t and s both has same eigenvalue 0 and 1, but they are not t not similar to same Jordan canonical form. So t and s not similar. So option 3 is wrong option. Only option 2 and option 4 is a right option. Next question, which had come also CSIR NET June 2024 exam. The question is, A is 4 cross 4 real matrix whose minimal polynomial x square plus x plus 1 and b equal to a plus I4, then which of the following statements are necessarily true? The minimal polynomial of b is x square plus x plus 1. The minimal polynomial of b is x square minus x plus 1. Option 3, b cube equal to I4. Option 4, b cube plus I4 equal to 0. For this, here max is x square plus x plus 1. This is actually minus 1 plus minus root 3i over 2, and this is actually omega and omega square. And we all of us know cube root of unity omega cube equal to 1, and 1 plus omega square equal to 0. This is the minimal polynomial of A, and A is given 4 cross 4 real matrix. We all of us know root of the minimal polynomial always root of the characteristic polynomial. Only multiplicity would be different. Since here only root omega and omega square, but A be given 4 cross 4 matrix, so root are such type omega, omega square, omega, omega square. This is the root of A. And B equal to A plus I4. These imply 1 plus omega, and 1 plus omega means minus omega square. Also 1 plus omega square, and 1 plus omega square means minus omega. Therefore, root of B would be minus omega square minus omega minus omega square. This is the root of B. And here the question about the minimal polynomial of B and B cube, about the question about the B cube. Since this is the root of the B, therefore the characteristic polynomial of B x plus omega whole square and x plus omega square whole square. Therefore, possibility of minimal polynomial of B x plus omega times x plus omega square. Other possibility is x plus omega whole square, x plus omega square whole square, because omega and omega square be the conjugate pair, always conjugate pair be the root. So possibility of these two. Now, which is the actual minimal polynomial of the matrix B? And for this minimal polynomial, the Jordan canonical form would be such type omega minus omega minus omega minus omega square minus omega minus omega. This is the Jordan canonical form for this minimal polynomial, and we have to check b plus omega times b plus omega square equal to 0. If b is similar to this, then b plus omega would be b plus omega equal to zero minus omega square 0. Sorry, here also omega square minus omega b plus omega minus omega square plus omega. Here also minus omega square plus omega, and b plus omega square, this value is equal to minus omega plus omega square. This is 0. This is minus omega plus omega square. This is 0. Therefore, b plus omega times b plus omega square, b plus omega times b plus omega square, this value is equal, and this value would be 0, 0, 0, 0. So, this is be the minimal polynomial. X plus omega, b plus omega plus b plus omega square equal to 0. And that imply b square plus b omega square plus b omega plus omega cube, which is equal to 0. That imply b square b times omega square plus omega cube. That imply b square minus b plus 1 equal to 0. So, option 2 is a right option. This is the minimal polynomial of b. Next, we have to solve b cube equal to I4. Since I have got b square minus b plus I4 equal to 0, that imply b square equal to b minus I4. Here we have to find b cube. For this, b cube, multiply this as b, then this imply b cube equal to b minus b. Sorry, b square minus b. And the value of the b square, b minus I4 minus b, here cancel bb, that imply b cube equal to minus I4. That imply b cube plus I4 equal to 0. So, option 3 is a wrong option. Option 4 is the right option. That means option 2 and option 4 is the right option. I hope my all viewers have understood this question easily. Okay? OL. Stop here. In my next video, I will discuss inner product space. Actually, linear algebra, this topic is very important for higher study. Okay? See you soon. And if you have any queries about this topic, please do comments in comments box. Thank you so much.